Welcome. Today we solve Check ASCII Palindromic. The question is, if we replace every letter with its 8-bit ASCII binary and keep the same order, is that big binary string a palindrome? We will explain ASCII, binary, leading zeros, palindromes, full dry runs, and the code from 0. What are we given? A string S of lowercase English letters only. We must build one binary string from every character, then return true if that binary string is a palindrome, otherwise false. The string length is at most 100, so a direct simulation is perfectly fine. What is ASCII? Every character has a number code. For example, A is 97, E is 101, F is 102, L is 108, and T is 116. First step for each letter, turn the character into its ASCII number. What is binary? Binary uses only 0 and 1. Small examples, 5 is 101, 6 is 110. For 8 bits, place values are 128, 64, 32, 16, 8, 4, 2, and 1. This problem always wants exactly 8 bits. 8-bit with leading zeros. 102 must be written as 011001110. 8 characters. Do not drop the leading 0. The problem requires fixed width 8. In Python, format of the code with 08b does exactly that. What is a palindrome? A string that reads the same forward and backward. Examples, A, B, A, or 0110. Non-examples, A, B, or 01101. To check, use 2 pointers from both ends. Left must equal right all the way inward. The full recipe. 1. For each character in S from left to right. 2. Get the ASCII code with odd. 3. Convert to 8-bit binary with leading zeros. 4. Append those 8 bits to one big string. 5. Check whether that big string is a palindrome. Preserve character order. Example 1S is FF. The letter F has ASCII 102, binary 011001110. The second F is the same. Concatenate to get 16 bits. 011001100110010. It reads the same both ways, so the answer is true. Why is that a palindrome? Pair the ends of the 16-bit string. Each left bit matches its right partner. 2 identical 8-bit blocks of F can form a palindrome for this bit pattern. A 2-pointer check confirms every pair. Example 2S is leet. Convert each letter. L is 108, binary 011, 01100. E is 101, binary 01, 100101. Second E is the same. T is 116, binary 0111, 0100. Next we concatenate all 32 bits. Concatenate leet into one binary string of 32 bits. Checking forward versus backward fails. The full string is not a palindrome, so the answer is false. Convert one letter carefully. Character F. Code equals odd of F, 102. 8-bit format gives 011001110. Check, 64 plus 32 plus 4 plus 2 equals 102. Repeat this conversion for every character in the string. 2-pointer palindrome check. Set left to 0 and right to the last index. While left is less than right, if the bits differ, return false. Otherwise, move left up and right down. If you finish without a mismatch, return true. No need to build a reversed copy, though reversing also works. Algorithm steps. 1. Start with an empty bit string. 2. For each character, append its 8-bit ASCII binary. 3. Set left to 0 and right to the last index. 4. While left is less than right, return false on mismatch, else move inward. 5. Return true. Time is linear in the string length. Binary length is 8 times the string length. Here is the full Python solution. Join format of odd of each character with 08b. Then return whether bits equals bits reversed. You can also use 2 pointers instead of reversing. For FF, this returns true. For leet, this returns false. Code walkthrough. Odd gets the ASCII number. Format with 08b forces 8 bits and keeps leading zeros. Join concatenates every character's bits in order. Comparing bits with bits reverse checks the palindrome. Short code, clear steps. Common mistakes. Forgetting leading zeros and writing 7 bits. Checking whether S itself is a palindrome instead of the binary string. Reversing character order while building bits. using the wrong bit width. Always verify the binary length equals 8 times the string length. Edge cases. For a single character, check whether its 8 bits form a palindrome. If all letters are the same, the answer still depends on that letter's bit pattern. Length up to 100 means at most 800 bits. Easy. Only lowercase a to z are guaranteed. Key takeaways. Each letter has an ASCII number. Convert each to exactly 8 binary bits. Keep leading zeros because width is fixed. Concatenate bits in the same letter order. Check if the big binary string is a palindrome. 2 pointers or reverse compare both work. Do not confuse S being a palindrome with the bits being a palindrome. That is, check ASCII Palindromic, explained from 0.